Hi everyone, welcome back to another new video. This is Praveen Kumar, Assistant Professor, Department of Computer Science with Cybersecurity. And today we are talking about the topic for memory management and techniques. And the memory management techniques are this is the five segmentations using in memory management techniques, and single continuous allocation for the entire memory is allocated to one process, and simple but inefficient for multi-programming. For example, expert in OS space. In signal continuous allocations, an operating system assigns a single continuous block of memory to each process. This method is simple and efficient for memory management because the CPU can quickly calculate address within the allocated block. In there are the advantage of simple to implement and efficient to access. And simple to implement, that is for the basics concept to is straightforward, making it easy for operating system to manage memory. And efficient access is, since memory is continuous, the CPU can quickly calculate the address of any location with process allocated block. Yeah, there are only advantages used, nothing but there are the disadvantages, and there are for the this is the primary drawback. So there are the disadvantage for this is the primary drawback for fragmentations, and the internal fragmentation, a process might be allowed more memory than it actually needs, leveling unused space with its allocated block. And paging. Paging is a memory management technique in operating system where a process virtual memory space is divided into fixed size blocks called pages, and the physical memory is divided into similarly sized blocks called frames. And the process and memory division for each process is broken down into fixed size logical memory blocks called pages. There are the frames for main memory. There are the frames, nothing but it is called for RAM. It's divided into fixed size physical memory blocks called frames. And the memory allocations for pages of a process are loaded into frames to the main memory needed. Virtual memory. Virtual memory is operating system provides a illusion of a large continuous memory space to applications even when physical memory is limited. It is achieves by temporarily transferring data between RAM and secondary storage. The virtual address space for each process has its own virtual address space, which applies as a large continuous memory area. The memory management unit for there are called for MMU. The MMU is a hardware component that translates virtual address used by the CPU into the physical address in RAM. Demand the pages for instead of loading the entire program into memory at once. Virtual memory use demand pages where only the necessary parts of a program. And the benefits of the virtual memory, it's a largest the program that allows to run that are larger than available physical RAM. There are the enables multiple programs to run uh, multi-programming or multitasking to used in RAM. They improved the memory usage for optimize the memory utilized by swapping pages between RAM and secondary storage as needed. It is how to it's working the virtual memory. First of all, the CPU generate the virtual address The CPU generates the virtual address accessing the memory. And the page fault, if recused the page is not in a RAM, a page's fault occurs. Continued executions, the process can then resume execution at the point where the page fault occurred. And thank you so much for watching this video.